Good morning, good morning. Hello, hello. In Arabic, Zayak, Kwais Kulu. Today I'd like to give you some new information concerning investigation of flint discovered by mixed Polish-Egyptian expedition in delta of the Nile, site Tell el Farkha. These flints were discovered some years ago, but now was time to make investigation, and we did some interesting observations. So, for examination were used three types of microscopes. First, binocular microscope of Polish production, and polarizing light microscope of China production. It's model Motic at so number at so, and scanning microscope production, United States production, with equipment used for chemical examination using EDS methods. So, there are flints tested. They were collected at various places at Tell el Farkha archaeological sites and represent various types of flints and various types of implements used for various for various use. These flints were tested using this binocular microscope, were made photos, and next were selected areas where are traces of work shown by these red arrows, and these fragments of flints were used next for scanning observation and scanning analysis examination. So each sample, each flint has his number, and we start from mineralogical observations using polarizing light microscopy. These observations were made at polarizing light at slightly cross nickels. The mineralogists know what I mean. And especially observations were devoted for determination of small cracks for selection for next step of investigation using scanning microscope. And we observe at some samples, number 2, 3, 4, 5, 6, and 8, we observe traces of small fissures filled up with some substances. It was interesting what is possible preserved at these small cracks. Maybe some materials having thousands of years, 5,000–7,000 years old. These areas were marked using marker and devoted for scanning microscopy observation. First we did observation of working edges of these flints using scanning microscopy. You see there is trace of work of flint number 2, traces of work, flint number 3. Not all selected samples were good for next step of observation. So we selected only 4 samples, number 2, 3, 4, and 7, where we observed traces of work, and it means was chance to find something what was what they used for these flints. And there are observations using scanning microscopy, areas of work, areas of destruction of the edge of flints. This is scale, it's quite big magnification, and we try to see what is inside in these small fissures, if it's something preserved organic or not organic. And we did a lot of photos, but now I show you only selected results. Next, sample number 3. It was near of the surface of the edge of working edge of flint. There is small hole and some substances present on the walls of this small cave. And sample number 4, this is enlarged fissure, which is about 5 micrometers wide. This means 0.005 millimeter, very small, 5 micrometers. And on the edge of this small fissure, there were some substances. We controlled these substances chemically. And flint number 7, and there's a small fissure there, and we tested this substance present on the wall of this fissure. The magnification is the same as on photographs shown before. It's 5 micrometers, very small fissures. And what we discovered, sample number 2, there are only crushed and slightly recrystallized quartz. Chemical analysis, seen as this spectrum, energetic spectrum, confirm present silica, oxygen, traces of carbon, maybe of organic origin, but it's difficult to say, and complete traces of magnesium. At fissure of sample 3, we discovered secondary crystallized calcite, CaCO3, nothing else, but it's of course probably of secondary origin. This fissure present at working edge of this flint was secondary filled up with the calcite. Sample number 4, at fissures of this sample, we discovered ferrum oxides. It means secondary iron oxides. What was discovered using polarizing light microscopy and confirmed by chemical analysis. Most probably these iron oxides probably hydrated like goethite or lepidocrocite, are of secondary origin, and these iron oxides migrate to these very small fissures present of working edge of flint. And there is no organic substances. Silica is connected with flint, and what is interesting, there are traces of phosphorus. Maybe its origin of phosphorus is because of the presence of the bones at archaeological layers. And 7, sample was interesting because at small fissures on the working edge of this flint, we discovered aluminium silicates, so clay minerals, very frequent in archaeological layers of Tell el Farkha. And this aluminium silicates migrated secondary to very small fissures at working edge of this flint. There are traces of iron too, some very small amount of carbon, maybe of organic origin, and chlorium, sulfate, and there are the most important are silicates, aluminium silicates, and iron. There are preliminary investigation and preliminary results. Analyses were made using a few samples, and maybe if the amount of samples of flints is bigger, results will be more interesting. In comparison to flints collected and examined at Castel Saga archaeological sites, Neolithic, there is very limited amount of organic substance. In Castel Saga, at small fissures of working edges of flints, we discover some organic substances, but area is completely of other climatic conditions, because Tell el Farkha is a humid region near of sea, a delta, so conditions for preservation of organic substance are very poor. In comparison to Castel Saga, where climate is very dry, humidity is 0.4, so it's very low, let's say, there is chance for preservation of some organic substances. As I said, on the other side, it's important to do more investigations this type as I show you now. So thank you very much for listening, and see you again next time. Bye bye, ma salama.